So right before we left for lunch, we were talking about sorting. We wrote that sorting network where it was a little machine and we put in 4 inputs. So one thing you think of once you've done that for your students with 4, you can then ask them, well, now what if I have 6 inputs? How do I expand that machine to handle 6 inputs correctly? And you can see how it starts to explode in terms of all the different comparisons and combinations that, if you try to do 10, it's just going to be kind of mind-boggling with all those connections. So then we lead into a discussion of general sorting algorithms. And we talk about why is it important to sort. So searching and sorting are 2 of the most fundamental things we like to do in computer science often. I mean, if you think about it, what is Google? Google is a search engine. And if we can have the ability to sort things, we have improvement over some of the things that we can do when we do the search. So I have an example here. You're going to see this coming right up. So if you're on the MOOC and you're caught up to Unit 3.3, this is one of the things I'm going to show you next. And we create our own blocks. So you've been dragging and dropping other predefined blocks. And with this example, we show you how to create your own. I'm not going to go through all that, but all I want to show you now is that this is a block that I created called search. And search takes 2 parameters. It takes the actual item that I want to search, and it takes a list. And the idea of search is it will return what's called a, this is returning an actual value. It's kind of like a function. So this search block will return the location in the list where item was found. So if I have a list of 10 things and I'm searching to see if item is in there, if item is inside of a list, it will return the index, or like which part of the list I found it. Otherwise, it will return -1. So if it returns -1, it means that item was not found in the list. Okay? So the logic of this, I have an index or a counter that I set to 1. And what I want to do is I want to loop over every element in this list. And so I'm repeating through the length of the list. And if item equals the index that's in the list, that is, if I have a set of items here in a list, I'm looking at each one at a time. So index is going through each one of these potential locations in the list. And if the thing I'm looking at is right here, when index is 2, I'm going to report or return the value 2 in this case, whenever index was 2. If I'm looking for a value that does not exist in this list, eventually index will come down, it'll reach the end of the list, my loop will end, and I return back -1 instead. So one thing you need to do is look at this logic and convince yourself why it works. Now there's one point that I make in section 3.3, and that, and I mentioned this the other day too, is that looking at code is much easier than writing code. This whole idea of generating or trying to speak a foreign language versus reading it. So my guess is if you sat here and went through the time and spent and looked at this a little bit longer, everyone in the room is going to eventually say, oh yeah, I see how that works. Now it's a different thing though for me to ask you to go and write that yourself. So that's why it's important when we give you on the MOOC these questions, these little activities to do, that you actually go out and struggle a little bit. Because if you don't have that, you're not going to be able to help your students. And they're going to have to struggle a little bit. So that kind of struggling is useful, and then you come back and ask us questions on Piazza or in the Help Out or Hangout, and then you can see the answer. So try to resist the tendency in the MOOC to watch the next video that has the answer. So struggle a little bit, then you can watch it if you need a hint or two. So this is the idea of looping through a list to search for an element. Now this list works interestingly well because what I'm doing, I'm just searching through each element. This works well when the list is not even ordered. So I could have a list 5, 19, 2, and 35. Suppose I'm looking for the number 2. This algorithm here in this search block will find the number 2 for me and report back 3. See why does it report 3? Well, number 2 is in the 3rd slot of that list. So there's the idea of the value that's in the list, and then its index or what slot it's found in. So this has 4 slots or four potential areas to stick the values. And in this case, this algorithm in search will return the number 3 if I pass in 2 and ask for 3. So if you look above here, I'm actually calling this block. So I created this block myself. and I have two say blocks where I'm just returning, what that will say is that the number, it will return either -1 or the number where it found it. So let me ask you a question here. What will this first block say? Jason, you want to help me with that? Can you tell me, can you look at that and give me an idea? What do you think that first block is going to say?
3.
Right, so search is going to go through here and find 3. It's going to report back when index is 3 because 3 is, the number I'm searching for 100 is in the third element of the list. Okay? Pam, can you help me? What is this second say going to say? Do you have an idea on that?
Would it be 2?
2? So what we're looking at, we're trying to see if 20 is in this list.
It's not.
So what happens when it's not? What do we return in this search? So when the loop ends, we haven't found it, we're going to report back a -1. So for things that we can't find, we report a -1. Everything else, if I put search 1,000, it's going to return 4, okay? Because it's in the 4th value. If I ask search for 500, it will return -1 because 500 is not in that list, okay? So try to look over this logic and convince yourself of that, and try to understand how this index is kind of keeping a loop of each one of these. Whenever we find a match, what we're returning back is the index, okay? So that's an example. You'll see this all, and we go over this a little bit more in detail in Unit 3.4. We show you how to create your own block. I haven't even done that. I just showed you what it looks like. And then we also show how to call that block up here. And then we go over the logic of searching.